Hello there, teachers and assessment enthusiasts. I'm Andrew, an IB Maths tutor who has been writing mock papers for the last 5 years for every IB exam session, May and November. So this is part 3 of a series where I share how I write mock exams for IB and A-level maths teachers specifically. I'm not sure if these principles are transferable to teachers of other subjects, but I hope that people find it somewhat useful. So in the previous part, we did all the prep work. So we discussed the purposes of a good mock exam, the characteristics of a good mock paper, as well as topic selection for the questions that will show up on the exam. This time around, we're going to focus on how to write the actual questions. So for this part of the video, please open the spreadsheet that I've linked in the description box and go to the sample paper 1 tab. Notice that to the right of the tab, you will see a table containing the number of marks per topic and per level of difficulty, as well as a series of constraints to make sure the paper is close enough to our requirements. We'll talk about it later. The lion's share of today's video will focus on how to balance question difficulty across the paper and within the question. A bit up on the level of difficulty before we move on. So for IB, I prefer to have 3 levels of difficulty. So easy for level 3, medium level 5, and hard level 7. This should correspond to IB levels 3, 5, and 7. But of course, my perception of a level 7 student seems to be quite different from IB's. In other terms, level 3, in my book, level 3 is the bedrock, the foundation that all students must be able to demonstrate. Level 5 questions usually contain a small twist on the fundamentals, or they're simply more algebraically demanding. Level 7 questions are intended to stretch the most able students. So ideally, even your highest achievers should not get 100% on the exam. Otherwise, the paper might have been a bit too easy for them. The IB key boundaries, aka the boundaries that the team examiners will decide together, are levels 3, 4, and 7. This means that after all the exams are marked, some examiners gathered in a room, and they will determine what level or what performance on the actual paper will correspond to grades 3, 4, and 7. The other boundaries are determined arithmetically. It's basically the same process for A level, except that it is determined at grades A and E. Moving on to the incline difficulty. So recall from part 1 of the question difficulty curve. So in the beginning, we should have some settlers or some easy questions that would lure students into doing the paper. As we progress through the paper, it will get progressively harder. Somewhere in the middle, maybe the start of the second half, you would chuck in an easy question. Just easy enough to keep students going, because they are like, from this point onwards, I can still do it. I can still have a go at it. Instead of, it's just gonna be pain and suffering from here onwards. For longer questions, we'll spend more time on that because they're trickier to write. Step 1, write the questions. So using the table of topics that you have developed in the previous part, it's now time to write the question at the intended level of difficulty. It is imperative to update the spreadsheet as you go along, and all the criteria will be updated automatically. Ideally, of course, you should develop the mark scheme at the same time as the question paper, But I know in practice it's kind of hard to do, especially when you're in flow. For for each question, you will include the code in the box, topic 1/2/3 or whatever, a number of marks, and a level of difficulty. It is perfectly fine to change your mind or to include more topics than you anticipated, aka the topics that you've decided in the previous step is not in the previous part it's not set in stone. However, don't add too many twists or an easy question will not be easy anymore. So keep that in mind. I also mentioned last time that we have some wildcards, aka questions that you did not touch in the previous step. Just leave it blank. We will come back to it later. Step 2, balancing the longer questions. Okay, in IB, this is O, section B questions. For A level, it's the last few 8 to 12 markers that are a bit tricky to write. As I've mentioned in part 1, you want the first part or parts, depending on the length of the question and the position in the paper, to be accessible to students. This does not mean that they are trivial. It's just easier than the last part of a previous question to motivate students to keep going. It is also very important that students can still access the rest of the question if they're unable to do the first part. So a way to achieve this is simply using shortcut questions or proof by induction for AAHL or for A-level further maths. Simply because students can plug into that expression and move on, even if they fail to complete the induction proof correctly. Here are my tips for writing longer questions. First off, test several topics in each question. Now, a single question can easily worth 10 to 20% of the entire paper. And we want to maximize the sampling domain. Here are some suggestions. Of course, you're not limited to this, but there's just some starting points that you might want to consider. My favorite go-tos. Curve sketching with calculus. You can never go wrong with this. If you feel a bit adventurous, you can make them sketch an unfamiliar trig function, like some powers of trigonometric functions as well. Exponential equations or exponential functions that they have not seen before, things like that. Can all go here. Combining integration and differentiation. This is classic. Example, find the area of the region bounded by the curve and the tangent to the curve at a given point and the coordinate axis, or between, two lines. This is another of my favorite. Various integrals that look very similar but require different techniques. Now, I would say this is a bit more controversial to include in exams, as they might say, okay, so that's like a little too many marks on integration, and this better suits as a teaching exercise. Well, yeah, maybe, but if you do it right, though, you can still test a very wide range of methods and very wide range of functions there as well. So why not? Let's just say a simple substitution versus a trig substitution versus a trigonometric integrals. We have 3 different kinds of integrals that require 3 different techniques, but all fall under the same umbrella of integration. Of course, we move on to trig identities and trig equations. They, of course, go together. Also test the notion of equality. Sequence series and probability is also interesting. I have seen IB does this several times. A level, not so likely, because usually prop stats and mechanics, aka applied math, are usually treated separately from the core or the pure A-level maths. For AHL, and A-level for the maths, you can also include questions about roots of unity or similar types. You know what I mean by that. Like you plot off the roots on the organ diagram, or you can also have some questions on the application of the Morpheus theorem and some applications in solving equations, for example, or finding integrals. Again, this is a way that you can tie several topics in the same question under the same umbrella. Tip number 2. Remember that the extent of queuing or scaffolding affects the difficulty of the question. In IB, some question parts are worth up to 10 marks. That's quite a lot. For A-level, most question parts are less than 6 marks. So there's more scaffolding there, I would say. So please keep that in mind when you're breaking up a long solution or a long question. Typically, the difficulty of a question increases as the student works through. So just remind yourself of the incline of difficulty curve that I showed earlier. The last part or parts of the question should either be long and discriminating but not hard, 6 to 10 marks. So it's going to be a very long procedure that is discriminating in of itself. In other words, it's not trivial that everyone will get it correctly, but it's simple enough that students who do know what they're doing will most likely get full marks or close to full mark. Or the short and crisp questions but require insights. These are usually worth 2 to 4 marks. For A-level, it tends to be evaluate this model. Voila. For IB, there's going to be some tricky question on what would happen if. It's usually what if scenarios that can go here as well. Examples. So this question was on the November 24 mark, which happened about 2 months ago. So this is one of my questions. So for this question, we looked at a rational function, in this case, a quadratic over linear. So part A is simply on calculating the discriminant and show it has no x-intercept. This question is honestly beyond trivial, but I just put it here for several reasons. One, it's very hard for students to go wrong with this. Two, considering the rest of the paper, I have not tested discriminant anywhere. So this just seems to be the perfect place for it. Part B is a simple derivative. Now, I can just tell them to find f prime without giving them the actual function. I can do that. It's totally fair. But I guess, okay, so my reasoning for this is that this is the first question in section B. So we want to make sure students are comfortable moving forward. So I give them f prime. It's going to be a short question. Everyone's happy. Part C is showing that the two given points are stationary points of f. Again, this is show that question, so it's not supposed to be that hard. Part D, now it gets trickier because there's not much scaffolding going on. Sketch the graph of f. Clearly indicate the equations of the asymptotes, the intersections with the coordinate axis, and the coordinates of the local extrema. We have discussed the intersection, that's part A. The y-intercept, they can do it themselves. The local extrema, that's part C. There is a slant asymptote or an oblique asymptote here that the students have to find themselves. One, so not much scaffolding over there. I did not state that there isn't a slant asymptote. I just tell them, okay, there are asymptotes, find them. And their job is to put it all together. Part E is sketching a function that is somewhat related to the previous one. So in this case, this question tests the understanding of modulus functions as well as a reflection. I did not spell out the transformation. So it's their job to find the relationship between G and F. And from the G that they just obtained, they're gonna flip it over, aka they're gonna take the absolute value of that. Not a lot of scaffolding here. This question is clearly level 5 because I don't provide too much hints. F is a fun one, which is a play on the shape of the curve. So if you actually sketch this function out, the function takes no the function the function is not how do I say this? So there's no value of x for which the value of y is between -10 and 2. That coincidentally also correspond to the minimum and the maximum value of the trig function I give there. So for the equation to have any solution, the extrema of the trig function has to overlap the extrema of the function f. So that's the thinking behind the question. It would make a lot more sense if you pause the video, get your hands dirty, have a shot at it. Here's the next one. This one was from the previous session. The one before that, so May 24. Part A, so for this question, I just give them a random function f that they do not know. And I give them the equation of the tangents. In part A, I just ask them to write down the values of f of e and f prime of e. So this is just reverse engineering the equation for a tangent line. Trivial. Part B, if y equals x ln of 2x minus e, show that y prime is whatever. This part is also very straightforward. Now, part C is where the party is. I give them a very fancy function g in terms of f, and I give them the gradient of the normal. I also tell them that the function g does not have a horizontal tangent at x equals e. So there's a lot of information to take on here. And all I tell them is find the value of a. Okay, so what do students have to do here? So they have to differentiate. After differentiating, they have to find the value of, the gradient of the tangent. From there, they flip over, take the negative reciprocal, they find the gradient of the normal. From there, they find the value of a. So this is quite a testing question. Steps are not laid out for them. They also have to make sense of an additional piece of information that G does not have a horizontal tangent. Something more for them to think about. So let's have a look at this question over here on your screen. Post the video if you want to have a go at it. Okay, so 10a is a question on trig identity. This is pretty straightforward, I gotta say. Also consider that this is question 10. So if memory serves me, this is the second question in section B on the mock IB exam. So it's fine for this question to be more challenging than the first one, or question 9. Part B is getting a bit trickier. Now, as usual, you should take a hint from part A. Looks like so the first part, the 2 tan of 2x over 1 plus tan squared of 2x, You know that is sine of 4x right there, right? The second term, based on part A, the second term seems to be, maybe it can be simplified. And it is, and it can be simplified. So that will make your life a lot easier. So part 1, after simplifying that expression, you are now down to sine of 4x plus sine of 2x is equal to 0. A relatively straightforward equation to solve. Part 2, find the values of m so that the equation has 6 distinct real roots. Okay, so now we gotta talk about, okay, so 6 distinct real roots. How are we gonna get that? So sine of 4x, that's gonna be 2 sine of 2x cos of 2x. So if you're gonna factor it sine of 2x out, you're down to 2 cos of 2x plus 1 minus m. You got to find the number of roots that the equation sine of 2x will give you. You then also got to find the number of roots that the second equation got to bring to the table so that you have 6 distinct real roots in total. Not an easy question. Part 3, write down the values of m so that the equation sine of 4x plus sine of 2x equals m sine of 2x has 9 distinct real roots. What is the difference here between the equation in B3 and the equation in part B? You have no restrictions for x. That also means that in B1 and B2, you most likely have had extraneous roots, as tan of 2x is not defined when cos of 2x is equal to 0, and cotangent of x is not defined when sin of x is equal to 0. Here, you don't have to care about that. Your job now is to find the relationship between B2 and B3. So this is kind of an insight question. It's not too hard. It's not too demanding. It's not like too algebraically demanding, but it requires some insight. C is, I would say, the most interesting part of the question, even though it's only worth 4 marks in total. C1 is proving that g of x somewhat in g of x to be an odd function. Okay. And what does it have to do with our question? And above C2, C1 is there to hint at the transformation. Because if you know that it is an odd function, what does it tell you about the function itself when you take the absolute value? Think about it. Moving on to the next example from Edexcel. So this is from Edexcel June 2023. This is from paper 2. And I love this question because it ties a lot of concepts together. In particular, this one covers, well, they call it the binomial theorem for negative exponents, but I just call it the Maclaurin because it is a Maclaurin series. So part A is finding the Maclaurin series. Part B is recognizing, okay, so we're not integrating the entire function. We're just going to integrate some terms of the Maclaurin series that we found in part A. That also means that, of course, you're going to have some error there. Part C is also finding the same integral, but now we're using algebraic integration, aka using substitution. So this question ties various concepts together. We have Maclaurin series, we have integration, and we are also testing whether they could tell the difference. Maybe that'll be a good addition to the question. Why is answer to B and C different? Another question from June 2023 from the same paper as well. So this is a question on the differential equation, and you're given a tank in the shape of a cuboid being filled with water. Part A is to show that dh over dt is equal to lambda over square root of h. We want to start with show that because part B will require students to solve this equation. If anything, and teachers definitely know this, when teaching topics like differential equations or optimization, the hardest part that most students have is with forming or creating the actual function to be optimized. So by doing this, you would give students who know how to solve equations the chance to actually solve equations, the chance for them to shine. And this is why I say that it's a good idea to use show that questions more often, and especially in the first few parts of a longer question. Okay, part B is simply solving the actual equation, so not much to discuss there. With two initial with the initial condition given. Okay, the part C is simply using the model that you have developed in part B. Again, a natural extension of the question. Because otherwise, what's the point of solving the model, right?